Hello dear students, topic number 6, physics for scientists and engineers, chapter number 24, molecular description of the dielectric. This is chapter capacitance and dielectrics. Okay, molecular description of the dielectrics. So basically in the previous lesson we discussed in detail the dielectrics are the medium placed between the medium or insulating medium that is placed between the plates of a parallel plate capacitor. So that here this one is the medium that is placed between the plates. This I use different colors. So for example, this blue is the medium that is placed between the parallel plate. So in this left plate the positive charge is stored, in the right plate the negative charge is stored. Okay, so as we know that there is an electric field line between the flowing from positive terminal towards the negative, from positive terminal towards the negative. The electric field lines start from positive and terminate at negative charges. Okay, so this is the direction of original electric field intensity that is represented by E naught. Okay, so what happens when we place a dielectric medium between the plates? As we know that this dielectric medium, it has this is the insulator, and in the insulator we know that the free charges, there is a free charges that are, I use different colors. For example, so as we know that these dielectrics has atoms. Initially the atom's center of this atom is proton, positive charge, and there is a cloud of negative charges, so that the center of these positive and negative charges coincide with one another. Okay, so initially the atom is neutral, but when we place this medium into the dielectric medium into the between the plates of a parallel plate capacitor, so that we know that this negative charge and there is a positive charge. Okay, so this electric field intensity, the negative charge is attracted by the positive plate, so that's why the center of this molecules or this atom shift, negative charges shift toward the left end and the positive charge is shifted towards the right end, because due to the attraction of this negative plate, right side plate. So it means this phenomena is basically polarization, so that there is a poles between the dielectric medium. In the dielectric medium we see there is a poles formation, minus plus minus plus. So this polarization, this is phenomena of polarization in the medium, minus plus. So that's why these minus plus, they will induce a field that is the opposite to the applied field. So they will induce, because you know that the electric field is always from positive terminal for the negative side. So the poles field is E induced field, electric field intensity induced is flowing from right to left, but the original intensity is E naught is from left to right. So they are opposite to one another. So that what is the total field of the dielectric is the sum of these two. Sum of these two mean the combination of these two. So as E naught is greater, so that's why total field E is equal to ED, dielectric field is ED is equal to E naught minus E induced. So E naught is greater, so that's why E naught minus E induced. So as we know that ED is equal to E naught over K. In the previous case we know that the dielectric case, the ED is equal to E naught original field divided by K, mean the field without medium divided by K. So we can rearrange this equation, so E naught over K. So but what we find, so I write again, so I write separately so that you can understand this one. ED is equal to E naught minus E induced, and we find E induced, that is equal to E induced is equal to E naught minus ED, but we know that ED is equal to E naught over K. So we can take E naught common, so we are left 1 minus 1 over K. So E induced is equal to E naught into 1 over 1 minus K. So this is the induced electric field intensity. I repeat again, so that the electric field by the original electric field by the from positive plate toward the negative plate is E naught from left to right, but induced electric field is from right to left induced. So that the total field is the sum of difference of these two values. Ed is equal to E naught minus E induce. Ed is equal to E naught minus E induce. So we found E induce, so E induce is E naught minus Ed. So Ed is E naught over K, E naught over K. And then we can solve, we took E naught common, so we are left with the E naught into 1 minus K. Okay. So this is the formula for E induced. Formula for E induced. Okay, 1 minute. Formula for E induced. Okay. Now we find the electric field intensity using Gauss's law. We know that according to Gauss's law, electric intensity E is equal to sigma over epsilon naught. So this is for electric field due to the plates, positive negative plates, but E induced is sigma induced over E naught. So this is electric field intensity induced by the poles molecule of the poles molecule of the dielectric medium. Okay. So in other words, this is for example medium, so negative positive, so E induced is this one, while applied field is E naught is in this direction. Similarly, so you can see that the E naught and Ed are opposite to one another. Okay. So sigma charge density can also be found by using this formula. Charge density is equal to same formula in the previous case, same we can find sigma induced is equal to sigma naught minus sigma d. So same formula we apply and we get sigma induced is equal to sigma into 1 minus 1 over K, and similarly Q induced is equal to Q into 1 minus 1 over K. Okay, thank you.